Hello, today we are looking at solving using a reference trig table. We've been solving these problems for a little bit now, and we have been solving these using a reference triangles, and we've talked a little bit about the shortcomings of this. Right now I have 8 triangles on this page that we've been using, and we've talked about how, this reference triangle, this is 60 over here, so I could also use it as a reference triangle for 30, because 30 has to be in this corner, but still that's a lot of triangles for us to keep looking at, so I can't squeeze all of them on this page. And so we talked about how is there a better way to do this, and what other people have come up with is something called a trig table, or a reference table for these trig values. And this is one version of what it looks like, so it's got a lot of different numbers on there. So we're going to be using this today in class. Make sure that you have one of these in order to take the notes, and make sure that you have a page for you to copy down these notes as well. Now personally, I would pause it and get these steps written down, because I'm going to go straight into the first problem. Real quick, another thing that you need is some sort of calculator. So I highly recommend that you use one of these calculators or a graphing calculator. I do not recommend for these types of problems using a phone calculator. I've seen a lot of people not do well with a phone calculator. So the first thing that we're going to do is we're going to identify the reference angle, which is 57 degrees, and go ahead and label adjacent, opposite, hypotenuse. So we have our hypotenuse, adjacent, and then this is my opposite. There's nothing there, so I'm not going to be using my opposite on this. Step number 2, identify the correct ratio and set up your work. Remember, I've been telling you a specific way that you must show your work, and we're going to stick with that method today as well. So since opposite is not being used, I didn't record it, but we are using adjacent over hypotenuse. So I'm going to write down adjacent over hypotenuse, and that's adjacent in regards to my 57 degrees. So far this looks exactly like what we've done. I'm also going to go back and label this as my reference side. And then my right side is going to be my given side. And when I say given, I mean the triangle that you were given in the first place. So these numbers on the left, my reference side, are going to come from this new trig table that we are using. So to use your trig table, you need to know 2 things. You need to know what your ratio is and what your degree is. So let me put this down in front of us. So we are using 57 degrees. So degrees is right here. We're going to go all the way down and we're going to find 57. So that is right here. The second thing is we are using this for A over H. So I've got my 3 at the top. I want to use the second column, A over H. So over here, this is the number that I'm going to be using for my reference table, 0.5446. So on this left side, I'm going to put 0.5446. And that is the adjacent over hypotenuse value with a reference angle of 57. On the right-hand side, my A over H, my A is the unknown, my H is 16. Now we've been solving these where we cross multiply, so I need to turn this into a fraction. Easiest way to do that is put a 1 on bottom. So now from here I can cross multiply. X times 1 is X. And then on the other side, so when I go to multiply this, I am going to do 0.5446 times 16. So I get this big long number. I know we normally say 3 decimal places, but since it's a terminating decimal and I only need to go 1 more in order for it to be exactly correct, I'm going to go ahead and include that 6. So 8.7136. Okay, now that we have solved, the last step is to check using the hinge theorem. Remember, the hinge theorem talks about the sides of the triangle, what should be the smallest side, what should be the biggest side, what should be the medium side. So I know I wrote it kind of small, but this is just a random triangle. So we've got 90 degrees, 20 degrees, and up here is 70. So what the hinge theorem says is that the smallest interior angle, the side opposite of it, so over here, 20 degrees is the smallest number, the smallest angle. So opposite is going to be the smallest side. And then between these two numbers, my 70 is smallest, so that means this is my medium side. And then 90 degrees, between these three angles, 90 degrees is the biggest. This has to be my longest side. So does it make sense that 8.7 goes right here? So 90 degrees, this has to be the biggest side, and this is going to be smaller. So is 8.7 smaller than 16? Yes. So the hinge theorem checks out. So we are good. I agree with this. Okay, I've got a couple more on here for you. So let me go ahead and zoom in on some of these. There we go. Okay, so we have opposite and adjacent. So if we remember back to our 3 trig values, we are going to use the one that is opposite over adjacent. And our value is 16 degrees. So we have opposite over adjacent for 16 degrees. And this is going to be my reference side. This is my given side. I like to write that on there every time so I don't kind of goof it up at all. So back to my reference triangle, or I'm sorry, my reference table. I'm going back over here, and so I need O over A for 16. So degrees, we're going down to 16, and we need O over A. So match these two up. 0.2867. 0.2867. And then O over A, so we have 3 over X. I'm going to add my 1 as the denominator so I can cross multiply. So we get 0.2867x equals 3. I'm going to have to divide by 0.2867, 0.2867. So x equals 3 divided by 0.2867, and I get this long number 10.4638995. Okay, you don't need to write down that long number, just go ahead and round it to 3 decimal points. So 10.46, and we are going to go up. So 464 is the correct answer I'm looking. And think back to the hinge theorem. So does this check out? 16 degrees, that means this is 74 degrees. So long side, or I guess medium, so long, medium, short. So this is the short side is 3, and 10, does it make sense that 10 is bigger than 3? Yes. So the hinge theorem checks out. Okay, second one, next example. So we've got, this is adjacent over hypotenuse. So let's set that up. A over H for 53 degrees equals A over H for 53 degrees for my given side and my reference side. So reference side, back to my table. A over H, 53 degrees. So double check, A over H, 53, 53. A over H, 0.6018. 0.6018 equals A over H. So we have 24 over X. So I can set this up with a 1 on bottom, and then I need to cross multiply. And then we'll need to divide. X again is a really long number, 39.88035892. Oops, getting kind of low. There we go. And so again, you don't need to write this, just go ahead and round it. 8 is approximately 39.880. Okay, this last one, what I want you to do is I want you to pause the video and go ahead and try this one on your own. Okay, so pause this video and I want you to try it on your own. Okay, so you should be using the O over H for this, and for O over H, you should be getting X is equivalent to 24.5504. No real need to round. Just go ahead and go all the way one more extra digit. But I need to see your work on here. This is the correct answer. Let me know if you have any questions.